My name is Jeff Kiernan. I am Commercial Director of Dawson Shanahan. Most engineering companies today are working to lean initiatives with the aim of improving their competitiveness in a very competitive global market. With high material and energy costs in manufacturing processes, waste reduction is a key part in achieving this goal. Dawson Shanahan are experienced with working with global OEM partners and getting involved at the early design stages. We would recommend that design engineers, when working on new projects, get involved with our process engineers to try to reduce waste at the outset. Also, with existing products, they also work with our manufacturer engineers on processes where our processes may reduce their metal waste. Cold forming is an ideal process to reduce metal waste. It also has the added benefit of reducing energy costs and recycling costs. I think the best way to describe it is the plastic deformation of metal into a predetermined shape at ambient temperature using high pressure and forces, a bit like working with Play-Doh. There are several methods of cold forming. There's cold heading, which automatically feeds wire into a transfer heading machine. It then takes that wire, crops it, and progressively cold forms it into the final component shape. There's also cold forming using mechanical and hydraulic presses. This takes usually a billet which may be sawn or cropped, is placed into the press where precision punch and die to a predefined shape, plastically deform the metal into the final component. This is sometimes referred to as forward and backward extrusion or upsetting. The third technique is orbital or incremental forming. This is an incremental process carried out on rotary type presses. Many engineering materials are suitable for cold forming. Copper is extensively used. Brass, aluminium, steel, and high tensile stainless steels can be orbitally incremental cold formed. In conventional machining techniques, a part uses material significantly larger than it, and using various machining techniques, the material is removed to produce the final component. In cold forming, a smaller billet is used and ideally is cold formed to the finished part shape. However, if this can't be achieved, a preform is produced which significantly reduces the amount of material required to make the part, and a small amount of machining is then required. Mechanical strength is better. With conventional machining, the machining process cuts through grain boundaries. Also, in cold forming, it work hardens the material, which can be beneficial. Superior surface finishes can also be achieved. And more importantly, very complex geometric shapes can be produced very quickly. Visit Dawson Shanahan. We can give you more information on cold forming, our other manufacturing and value-added services, and we have produced white papers, videos and case studies which you can see on our website www.dawson-shanahan.co.uk.